Hello everyone, welcome back to my channel Reactive Minds. Hope you all liked the last video. Today I'm back with another exciting, interesting and easy topic, that is balancing the reaction. Now we will be discussing few examples regarding balancing the reaction. Firstly, I have considered a very simple reaction between a hydrogen and oxygen molecule to form water molecule. I hope all remember the first step what we discussed earlier. That is, in the first step we have to divide the reactions into LHS and the RHS. That is, reactants in the LHS whereas products in the RHS. Now list the number of molecules present in LHS. So the number of hydrogen atom in LHS is 2, whereas number of oxygen is also 2. Coming to the right hand side, the number of hydrogen is 2, whereas the number of oxygen is only 1. So the number of hydrogen in both the sides are equal, but the number of oxygen in both the sides are not equal. So what we can do? We can just multiply 2. So we'll get, in RHS, we'll get 4 molecules of hydrogen and 2 molecules of oxygen. But unfortunately, there is only 2 molecules of hydrogen in LHS. So if we multiply 2, then we'll get 4 molecules of hydrogen in LHS as well as in RHS, and 2 molecules of oxygen in LHS as well as 2 molecules of oxygen in RHS. Thus, the equation is balanced. Next, let us consider another example. Here I have considered the reaction between iron and water molecule. Now let us divide the reaction and count the number of molecules. Here the number of molecules in LHS is as follows. The number of iron in LHS is 1, hydrogen is 2 and oxygen is 1. Whereas the number of iron in RHS is 3, oxygen is 4 and hydrogen is 2. So here the number of the iron molecules in both the reactions are different. So what trick can we apply? If we multiply 3 in LHS, the number of Fe molecules in both the sides will be equal. Now we can see another difference, that is, the number of oxygen in both the reactions are different. So if we multiply 4 in the place of LHS, we'll get 4 molecules of oxygen in both the sides, but the number of hydrogen molecules will differ to 8. Thus, we can multiply 4 molecules in RHS as well. Now, the equation is balanced. Iron molecules are same, oxygen as well as hydrogen molecules are also same. Now, coming to example number 3, here if we divide the reaction and see the number of molecules, in LHS, the number of molecules of iron is 1, whereas Cl is 2, sodium is 1, oxygen is 1 and the hydrogen is 1. Whereas in RHS, the number of iron is 1, oxygen is 2, hydrogen is 2, sodium is 1 and the chlorine is 1. Now if we observe the reaction, in that the number of the Cl in both the sides are different. So we can multiply 2 in place of RHS. If we multiply with 2, the number of the sodium molecules will differ. So in order to balance the reaction, we need to multiply 2 in LHS as well. By multiplying 2, the number of oxygen and hydrogen also becomes 2, which is same in RHS as well. Thus, the reaction is balanced. The number of iron molecule is 1, chlorine molecule is 2, sodium molecule is 2, oxygen is 2, and the hydrogen is 2 in both the reactions. I hope you all understood the trick to balance the reactions. In fourth example, I have considered the reaction between lead nitrate and sodium sulfate. Now, let us count the number of molecule in both the sides. The number of lead molecule in LHS is 1, nitrate is 2, sodium is 2, sulfate is 1, whereas in RHS, lead is 1, sulfate is 1, sodium is 1 and nitrate is 1. Now, we can observe a difference, that is the number of sodium molecule in LHS is 2, whereas in RHS it is 1. So, if we multiply with 2, we'll get 2 molecules of sodium and 2 molecules of nitrate in both the sides. Thus, the reaction is balanced. It's so simple, right? I hope you will try another example by yourself. So, in the next slide, I have given a reaction so that you can work out and find yourself and balance the reaction. And the answer will be in the description box. Hope you liked the video. Please don't forget to like, share, comment and subscribe. For fresh contents, keep watching Reactive Minds.